Hi, I'm Dr. Asad Naeem. I teach at a civil engineering department at a public sector university in Pakistan. I'm a PhD in structural engineering and a licensed professional engineer accredited with Pakistan Engineering Council (PEC). This semester, I'll be your instructor for the course of Advanced Strength of Material, which is also known as Mechanics of Material or Mechanics of Deformable Bodies. I cannot wait to get started with you to learn more on this subject. So, let us begin.
Concepts of Poissons ratio. Let's go ahead and look at an example. So there is a structural member of a steel structure and it is to be tested, and it is made of a rectangular section. Okay, so we can say that we took a structural member of that building and we want to test it and find its material properties, and one of them is Poissons ratio. So it's going to be a rectangular steel alloy. Poissons ratio. We have nu equals to minus lateral strain, which is this width direction, which is 0.014 divided by its original width, which is 50 millimeter. So this is our lateral strain divided by the longitudinal strain, which will be equal to 2 millimeter divided by 2000 millimeter, and it comes out to be 0.28. So this is our Poissons ratio. So okay. So here's a video of a typical tension test with the specimen attached to the tension test apparatus. As the load increases, the specimen continue loaded, and we will notice that it starts to neck down and the cross-sectional area at this position reduces. However, that the specimen get elongated in this supposedly y direction, and finally it fractures. As we see this is the fracture point. Okay, so this specimen is actually 1/4 inch of a diameter of steel, and the stress and strain can be calculated using the strain gauge or and the applied load using the manual gauge or using a computer. So okay, let us continue and go ahead and understand the different parts of a normal stress and strain diagram for a typical tension test.
Special moment resisting frame and intermediate moment resisting frame, because these are building structures type that we built in the high seismic zone. One of the most important part or the critical part is the transverse reinforcement, which you all know is stirrups or hoops in our supporting members. You should make sure that at the site or the contractor provide the seismic hook. So here is an example of the seismic hook, as you can see. I will also show you the exact so here, if you see, this is the seismic hook provided at a 135 degrees. This hoop helps to resist the shear forces that is acting due to the earthquakes in columns and in also beams at the hinge location. And this is a kind of a ring that you can see, and here is the normal with the 90 degree. This is the 90 degree hook, and that was 135 degree hook. Another one of the important point is that the parameter reinforcement should be accompanied with the cross ties, or it should have the stirrups, and this is the example of a cross tie. This is the 135 degree hook and this is 90 degree hook. So it's also used for the seismic design of building structure.